Alright, today we're going to start talking about 11.1 graphing and transforming y equals x squared. But before we start looking at that, let's take a little trip down memory lane and look at the graphs of y equals absolute value of x and its transformation y equals 3 times the absolute value of x minus 2 plus 3. So go ahead and graph those on the two graphs that are given below. Go ahead and pause the video, and then in about 2 or 3 minutes we'll go over the answer. Alright, so here we see the graph of, on the left, the parent function y equals absolute value of x. So we got to remember from that the vertex is going to be at 0, 0. The right side is going to have a slope of 1. The left side is going to have a slope of negative 1. Then when we go to transform it, we went right 2 spots, up 3 spots, and then the slopes changed from 1 and negative 1 to 3 and negative 3. So these ideas, this x minus 2 moving us to the right 2, this plus 3 moving us up 3, this 3 out front here changing our slope to 3, are going to be the same ideas that we're going to use for y equals x squared. So in this table here we see what each of these different transformations does. So our parent function here would be absolute value of x, x squared. A horizontal shift of h places would be x minus h inside of an absolute value, or x minus h inside parentheses that are going to be squared. Then our vertical shift, just like the plus k, would be outside of our absolute value. Our plus k is not inside, it's outside of the parentheses with the x squared. Now I put a little asterisk here. Just remember that the horizontal shift goes in the opposite direction that we think it should. So in that last problem it said x minus 2 inside the absolute value. Minus 2 we would generally think go left. Remember that means to go right 2 spots. So if all we have to do is know these rules that we already know, the basic thing that we just have to learn that's new is what does the graph of y equals x squared look like? What are some pieces that we need to know? So the important stuff is going to be what the graph looks like, the vertex, the axis of symmetry, the concavity, domain, and range. So to figure out what the graph looks like, let's go ahead and fill in this xy chart. So if we take negative 2, and we put it into x squared, negative 2 squared is going to be a positive 4. Negative 1, plug it in, negative 1 squared is going to be 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. You need to know these 5 points for your parent function of x squared. So on the absolute value, you only needed negative 1, 1, 0, 0, 1, 1. I want you to go one step farther and know negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4. And the reason for that is these 3 points here are the same. So I want to make sure that we kind of see the curvature by getting this 2, 4 in there. So looking at this, we go left 2, we're going to go up 4. If we look closely, each of these marks here is actually worth 2. So left 2, up 4, it's going to be there. 1, 1 is going to be halfway, halfway. 0, 0, 1, 1, 2, 4. And it's going to open up like this. It's going to have a curve to it. And this is called a parabola, if you didn't already know, but I'm pretty sure you did. So the shape of this graph is called a parabola. Now the vertex is going to be at 0, 0. And there's this thing called an axis of symmetry that we didn't talk about with the absolute value that's new to the parabola. The axis of symmetry is going to be the vertical line through which our parabola is symmetric. So if we think about it, if we fold the parabola along this dotted line right here, we're going to be sitting on top of itself. So this axis of symmetry, in this case here, is going to be the line x equals 0. Now, something that is always going to happen, this will always go through the vertex. So if you know where your vertex is, your axis of symmetry is always going to be x equals whatever the x coordinate here is. Concavity. This just means which way does it open. Does it open up like a smiley face? Does it open down like a frowny face? So the concavity here is going to be concave up. Domain. Well, how far left? This thing's going to go all the way to negative infinity. It's going to go all the way to right to positive infinity. So our domain is negative infinity to infinity. Range, this graph goes as far down as 0. It hits 0, so we're going to go bracket with a 0. It's going to go up to positive infinity, so our range is going to be 0 to infinity. And the range is always going to be like that. It's going to be from wherever your vertex is, either up to infinity if we're concave up, or down to negative infinity if we're concave down. So, there's a few examples that I'd like you guys to try on the back side of this. So let's look at the first two. So we want to graph x minus 1 quantity squared and x squared plus 4. I want you to find the vertex and the axis of symmetry. So go ahead, pause the video. In about 4 or 5 minutes, we'll go over the answer. Alright, so before we talk about the answers here, I want to point out that I messed up the scale on the previous graph. I didn't notice that we went by 1s on the x-axis and 2 on the y-axis. So I've fixed it on here, but just be cognizant moving forward that the axis, x-axis is 1 here and the y-axis is 2 going up this way. So this minus 1 just means we need to go to the right one. So our vertex was at 0, 0 originally, and we move it right 1. So our vertex is now going to be 1, 0. Then our points, we would go up 1 over 1 in each direction. So we go up 1 over 1 to get this, up 1 over 1 to get the other point. So that would be the equivalent of 1, 1, negative 1, 1. Then our other points were 2, 4. So from here we had to go over 2, up 4, over 2, up 4. So this would be the equivalent of negative 2, 4, and 2, 4. And then we make our graph going this way. Our axis of symmetry on this one, remember the axis of symmetry is always going to go straight through your vertex. So our vertex is at 1, 0, so our axis of symmetry is x equals 1. On this one, our plus 4 just had us go up 4 spots. So we move everything from our parent function up 4 spots. So the 1, 1 meant go over 1, up 1, over 1, up 1, over 1, up 1. And then we had 2, 4, which meant go over 2 spots, up 4, over 2 spots, up 4. Our vertex is now at 0, 4. And our axis of symmetry is still going to go through our vertex. So it's going to go through the point, or I'm sorry, not through the point, but it's going to be the line x equals 0. So there's 2 more I want you to try. So go ahead and try C and D, and then pause the video in a few minutes, maybe 5 minutes or so. We'll go over the answer. Alright, so the left graph function C, x minus 3 quantity squared plus 3. The minus 3 tells us to go right 3. The plus 5 tells us to go up 5. So our vertex is going to be over 3, up 5, so at 3, 5. We want to go over 1, up 1 in each direction, over 2, up 4 in each direction. Our axis of symmetry is going to go through our vertex, so our axis of symmetry is going to be x equals 3. D, f of x equals quantity x minus 1 squared plus 2, so we go right 1, up 2, so right 1, up 2, over 1, up 1 in each direction, over 2, up 4 in each direction. So our vertex is going to be at 1, 2. The axis of symmetry is going to go through our vertex, so it's at x equals 1. So that's going to do it for the lesson. Go ahead and start on the homework. It will be checked tomorrow.